In this video, we'll be talking about the effects of heat. Look at these two videos here. On the left, we have an ice cube that's slowly melting and becoming water. This is basically a phase change where a solid is becoming a liquid, right? And on the right, we have a cup of tea from which steam is rising, right? And in this scenario, a liquid is turning into a gas, right? Now, how does all this happen? Why does a solid want to turn into a liquid and a liquid turn into a gas? To answer that question, we need to explore the effects of heat on objects, because it's heat that causes these changes to happen. Let's dive right in. Okay, so an ice cube is turning from solid to liquid. Let's see how a solid looks. This is how the particles of a solid are packed together. They're very tightly packed together. On the other hand, a liquid's particles are not so tightly packed together. So how does a solid then become a liquid? What happens is a solid absorbs heat from its surroundings, and this heat causes the particles to start vibrating. Let's take a closer look. The particles within the solid get excited because of this new heat that it has received, and because of that it starts jiggling up and down and left and right, and that jiggling causes this particle to move around and strike its neighbors. And when that happens, the particles begin getting separated by a distance, because now they're just bumping into each other and they're trying to break free. So some of the particles, go away, and then you are left with a liquid where the distance between particles is much greater than in the solid, right? Okay, so just to summarize what happened, heat got absorbed by these particles started jumping because of the heat, and then they pushed each other away, and the solid became a liquid. So how does a liquid turn into a gas? A liquid has molecules packed somewhat like this, and a gas has molecules packed very, very loosely. Now, how does a liquid turn into a gas? The concept is the same like the previous one. The liquid absorbs heat from its surroundings, and when that happens, these particles want to jiggle again. And because they want to jiggle up and down, and they want to vibrate, and they get excited, and they start colliding with other particles, and that causes the particles to move away from each other, and that is what turns a liquid into a gas. Okay, so a solid can turn into a liquid when it absorbs heat from its surroundings, and a liquid turns into a gas when it absorbs heat from its surroundings. Now, my question for you is, can the reverse happen? Is it possible for a gas to turn into a liquid and a liquid to turn into a solid? Well, it definitely is possible, because we know that the water vapor coming out of this cup can be collected or condensed onto some kind of plate, and we would be turning gas into liquid if we did this, right? And we know that the liquid could then be collected into a container and frozen, and we would end up with ice. So we can turn a gas into a liquid and a liquid into a solid. But the question is how? In all the previous examples, when we were turning solids to liquids, we wanted the solid to absorb heat. And when the liquid was turning into gas, we wanted the liquid to absorb heat. In this scenario, we're going to do the opposite. To turn the gas into a liquid, we need to remove heat from the gas. To turn a liquid into a solid, we need to remove heat from the gas. And that's precisely what a refrigerator does when we place water into a refrigerator. It removes heat from the water, and then it makes it cold, and then the water turns into ice, right? So what we essentially want to do is cooling. Okay, so that was the idea of turning a gas into a liquid and then into a solid. Now, we did understand that heat causes phase changes between solid, liquid, and gas, but does heat do anything else to objects? Well, here's another example of something that heat does. Heat causes expansion of objects, and that is called thermal expansion. Now, it's a very fancy word, but it's very simple, and I'm sure you've seen examples of this in your daily life. Have you ever found that during summer, a particular door or a particular window just doesn't shut? That's because of thermal expansion. Supplying heat to an object can cause a certain kind of expansion to happen, and that's what we're going to discuss now. Well, let's say you take a scale, a ruler, a steel ruler, and let's say you start heating this ruler. As the temperature increases, what you will see is that the ruler begins to expand. The expansion may be very small and maybe even very, very hard for the naked eye to observe, but you will notice that there is a certain amount of expansion in the scale when you heat it. Okay, how do we know? Well, if you quickly compared it to the old ruler, you would see that there's a small difference in the sizes of these two rulers, right? And that small expansion is what we call as thermal expansion. Now, it must be clear that when we cool the ruler, it returns to its original size. This is not a permanent change, but rather a temporary change. Okay, and you'll see this concept all around you. Let me show you a few examples of where this concept is used in our daily lives. Well, I'm sure you've seen such a thermometer at the hospital or even at your home when you wanted to measure the temperature of your body. You use something like this. And let's try to understand how the thermometer is constructed. In this thermometer, there's a small tube, and this tube has some mercury within it. When the thermometer is placed inside the mouth of a human, you'll notice that this mercury begins expanding. Why? Because the mouth of the human is warm, and that causes this mercury to expand. When the mercury expands due to the supply of heat, you'll notice that it starts rising up this tube. So what's happening here is when heat is applied to the mercury, the molecules of mercury start vibrating, start jiggling against each other, start hitting against each other, colliding, and that causes an expansion, and that causes the mercury in the tube to rise. Now, once the molecules don't want to hit each other and expand more, the mercury level stops rising, and one can then note down the temperature. So this simple concept of expansion due to supply of heat is used in this thermometer, and it is very effective to measure temperature of patients in hospitals or at home. Where else can we see the use of this concept? Another very interesting example is expansion cracks. Let me show you what that means. Now, this may seem really weird, two weird unrelated pictures. Let me explain. Let's zoom into the first picture. This is a concrete floor where some gaps have been left between these blocks of concrete. Why would someone leave a gap in the floor? Wouldn't that make the floor all bumpy? Yes, it does make the floor a little bumpy, but there's a huge advantage to doing this. These gaps between these concrete blocks provide room for expansion during hot weather. Let's say this floor was constructed in winter, and in summer the temperature increases, which causes the stone to expand. And if the stone expands, there needs to be some space for it to expand. And that is what this expansion crack does. It creates some space so that expansion of these rocks or these blocks can happen. I have another very nice example here, and that is a railway track. On a railway track, you'll notice that there are often points where there's a crack in the tracks. Now, this is not some kind of defective railway track. This is built on purpose like this. Why? So that a small crack is left between two pieces of the tracks, because in summer or during the day, you will notice that this steel will want to expand. And when the steel wants to expand, there needs to be some empty space for the steel to expand. And the crack provides just that.